Okay, let's discuss a question from radiation. There are three cylinders, long cylinders, infinitely long cylinders, and they are placed as shown in the figure, and you have the geometry, basically the diameters given and the emissivity values are given. So understand one thing, that heat flows from 1 to 2 and then 3 to 2 depending on the, because one is at higher temperature, I guess. Yeah, one is at 1500 Kelvin and T3 is 250, so it will be flowing from 1 and 3. 2 is sort of a barrier. Okay, so thing is that how a heat transfer, let's just write down how heat transfer flows between one and from surface 1 to 2. How do we accommodate? So if you consider about the radiosity, as basically radiosity is nothing but the surface resistance to your heat transfer. So if you consider entire all that thing, the surface radiation, and between 1 and 2 the mutual radiation, so all that if you consider, it boils down to this equation, T1 power 4 minus T2 power 4 by 1 minus epsilon 1 by A1 epsilon 1 plus 1 by minus epsilon 1 by A1 epsilon 1 by 1 by A1 F12, that is the shape factor between 1 to 2, and 1 by A2, same thing, 1 minus epsilon 2 by A2 epsilon 2. So this is the radiative heat transfer between body 1 and 2, which are non-black and which are long. Okay, so that is this is a general, I mean, for any two long body. Okay, and the heat transfer between 1 and 2, that this is the basic thing. Now under steady state, from the given problem you can say that under steady state, whatever 2, if 2 is at a same temperature, so whatever 2 receives from 1, it has to give it to 3, so Q12 has to be Q23. So applying the same relation, so what we get is sigma, this is T1 power 4 minus T2 power 4 by 1 minus epsilon, so that is 1 minus 0.8 by 0.8 A1, okay, by 1 by A1. F12 is what fraction of heat transfer that leaves 1 and reaches 2. I mean, it's all 1 because it's long, so whatever reaches 1 will go to 2 only, right? So F12 is 1, and similarly F23, that is whatever is radiation leaving surface 2 will reach surface 1. Okay, so A12 is what fraction of radiation that leaves 2 reaches 3, so it's completely 1 because, yeah, so A12 is, okay, and then 1 minus 0.8 by 0.882, so this is between 1 and 2, and between 2 and 3 is T2 power 3, but in a similar way we can write down, so 1 minus 0.8 by now A2 here, A2 0.8 1 by, so this will be A2, F12 is 1, and 1 by minus 0.8 by 0.883. Okay, so we have got everything now placed. So now remember that A1 by A2, now A1 will be your the lateral surface area, that is pi d1 into L being long, so, and A2 is d2, so it is basically boils down to d1 by d2, and similarly for A2 by A3 also we can write d2 by d3. So these equations, if I take the ratio A1, if I multiply, I mean, A1 on both sides, okay, A1 on both sides, so A1 if I take at the top into sigma, T1 is 15 power 4, so if I multiply both on the left side, if I multiply both on the numerator and denominator A1, so what do I get? So T2 power 4 by, so this is 0.2 by 0.8 plus this will be 1 plus A1 by A2 will be there, which is D1 by D2, and that is 5 by, if you go back to the question, 5, 10, 15, so it is 5 by D1 by D2, 5 by 10 into 0.2 by 0.8. So this is what is on the left side. The right side, if you multiply the same thing on the numerator and denominator A2, so what I get is A2 and sigma T2 power 4 is something which I need. Here is 250. Just check, let's check whether it's 250. Yes, T3 is 250 Kelvin. So we are substituting in Kelvin, it's directly given in Kelvin. So 0.2 by 0.8 plus 1, because I am multiplying A2 in the denominator, so A2's gets cancelled, and this is 0.2 by 0.8, A2 by A3, which is 10 by 15. It's in the Bishop diameter. So sigmas gets cancelled, and here also A1 by A2 I can write D1 by D2, which is 5 by 10. So if everything is known here, so T2 we get an expression in T2 power 4 which is quadratic, and T2 we get T2 power 4, and once we take the quadratic, so it's, I mean, we get the fourth power. So if you do everything and take the fourth root, we get 1160. So the answer is 1160. So it's really a simple problem. Only thing you have to understand that basically first thing you have to remember this equation, and then you have to apply that in steady state. Q12 is equal to Q23. The answer is A, 1160 for T2. Thank you.